Hey there guys, Paul here from theengineeringmindset.com. In this video we are going to be looking at the VAV system. VAV stands for Variable Air Volume. VAV systems are very common in offices. This is because they are much more energy efficient compared to the CAV model, which is a constant air volume, and they also allow zoning within the building. And that's really handy because not every room in the building will experience the same heat load. But with a VAV system, you'll be able to control the amount of cooling, or possibly heating, into each of the rooms individually from the same main ductwork and main AHU system. So as you can see here, we've got just a mock-up of a very basic office. So we've got the main AHU sited over here in the plant room. Then we've got the supply duct, which runs along here and goes to all the rooms within the mock-up of the building. And then on the other side, we've got the return line, which comes back to the AHU. And then it can either be chucked outside if it's dirty air, or some of it can be recycled and used again throughout the AHU. If you're new to HVAC and AHUs, then I highly recommend you check out some of our other videos, such as the fundamentals of HVAC, basics of HVAC. This covers a lot of the material in the AHU, what you typically find in each one, so I highly recommend you go back and have a look at these. There's also a link appearing above you now. Now, in a VAV system, the air coming out of this supply AHU and through the supply duct, the air is running at about 13 degrees Celsius or 55 degrees Fahrenheit, and that will flow all the way through to the end of this duct here, where each of the rooms can feed off of this and take some of that 13 degree or 55 degree Fahrenheit air as needed. That air distributes into the room through these diffusers, spreads across, and then, as you can see at the back here, there is the return grills where the air, or the dirty used air, is picked up and sent back to the AHU. So the main difference in a VAV system compared to a CAV system is this, the VAV terminal. So this is located just on the branch coming off of the main duct, and each VAV box serves a certain zone. The VAV box is connected via this cable here to a thermostat which is located within the room or the zone, which needs to be controlled specifically by this VAV box. The VAV box looks something like this, where we've got the inlet coming off of the duct, the main supply duct. We've got the main VAV box or terminal, and then we've got the exit or the supply here going off into the zone. If I just make these sides transparent so we can have a look inside. And there we go, now we can have a look inside the VAV box, or VAV terminal as it should be called. You can see it's a pretty basic box actually, there's nothing too complex happening inside these. So we've got the controller located here, mounted onto the actuator. The actuator controls and rotates this shaft, and connected to the shaft is this damper. The damper can modulate its position to control the flow and the amount of air entering into the box and thus entering into the zone. The air entering the box, like I said, is around 13 degrees Celsius or 55 degrees Fahrenheit typically, but this temperature can be adjusted via your BMS. Sometimes that isn't warm enough, so we've got an electrical reheater here which will switch on, and it will then just warm that air up as it passes through. You don't necessarily have to have this inside it, but it's fairly common. They don't necessarily have to be electric either. They could also be fed from your hot water system, or it could also be from, say, a heat pump or something like that. But for simplicity, I've just left it as an electrical reheater. On the back side, looking in through the inlet here, you can see these tubes which are coming from the controller, and off, entering into there and connecting to this weird cross shape. This is an airflow sensor, and it's basically measuring the change in pressure across this device, and from that you can average this and calculate the air velocity or flow rate into the VAV box. Now this works a little bit like a pitot tube, if you know what that is, but it's not quite the same in how it works, but I think we'll leave that for another video. But basically all you need to know about this is there are some small kind of pinholes along the front surface here and also on the back of it. And if you imagine we've got the supply air coming in here and hitting the front of this, then it's going to impact on this and cause a pressure, so it's going to have a high pressure side on the front here, and obviously on the back side you're going to get a low pressure point. You can find the differential pressure across the device, and if you average that for the size of the duct and calibrate it a bit, then you can calculate the flow rate of air entering into that box and zone. Let's just show you what some of the components look like. So this first part here, we've got the damper. Here you can see the air velocity sensor and also the damper. So this is looking through towards into the VAV box. And then looking at the controls point of view, we've got the thermostat, the air velocity sensor, the controller, and then the actuator. Don't forget, the actuator is the device which controls the position of the damper inside the duct. Now the damper never really closes fully, or at least typically it doesn't, and that's because you still need a certain amount of fresh air to enter into the space. So air can still get past this and through and into the zones which the VAV box is controlling. But if you've suddenly got a higher heat gain within the room or in the zone, and the temperature in the room starts to rise above the desired set point or the desired temperature of the room, then the damper will start to open, and this will allow more air into the space. Remember, the air is about 13 degrees Celsius, 55 degrees Fahrenheit, so that will start to cool the room down and force all that hot air off into the return duct. In the middle of summer, when you've got all the solar heat gains coming through the windows, and maybe you've got a meeting room and it's full of people, so there's a lot of heat being generated in there, so the damper will open to 100%, and this will let as much cold air in as possible, and this will then flood into the room, into the zone, and start to disperse some of that heat. But during the winter and throughout the normal part of the day, when there's less people in the room, then the damper's position is further towards the closed position, remember, not fully, and this modulates the cooling. Now if you imagine these VAV boxes which are connected to the system here, as they can all vary the amount of air which is coming and filling into the space before being returned to the AHU, as they vary that amount of air, then these dampers will start to close. And as they start to close, these fans here in the AHU are still pushing out as much air as possible into this. And that's going to really increase the pressure in these ducts. So what we want to do is fit a pressure sensor here towards the furthest point in the duct to get the most energy efficient operation. And these are connected over to the VSD, the variable speed drive or the variable frequency drive. The VFD is connected directly to the fans, the fan motors, and the VFD will then slow the fans down, slow the induction motors down, and this will reduce the amount of air being pushed into the duct. The pressure sensor is set with a set point of where it should be operating at, or what that pressure should be at that end of the duct, and the fans will reduce in speed to reduce the amount of air being pushed into there to match that pressure point. And that means the fans use way less energy, and your main AHU cooling coils will also use less cooling as well. Obviously the added bonus is that each of the rooms are classed as a zone, and they can all be controlled individually to meet the specific requirements of that room and the heat gain within it. You can also get some fan assisted VAV boxes, which you can see this box on the side here, there are a lot of variants you can get on VAV boxes. So this is the most simple version I could make to show you and help you understand this. And I'll just show you inside the model of that as well. So it's essentially the same. Once you can see the panels have been hidden here. So we've got the filter here where the air from the space will be coming back into and forcing in through this fan into this chamber, and that will then mix with this as the damper opens, and so the cold air and the warmer return air from the room will be mixing in here, and that will and can pass through the heater battery if required and off into the zones. And that's useful because the fan will keep a constant volume coming through the box. So if you imagine as that damper closes, then less air volume will be coming through. So the fan will ensure that a consistent volume is coming through that box. You get the air turnover in the room. And it also reduces the chances of cold air being dumped out of the diffuser onto anyone sitting below, as that would be very uncomfortable for them, and the staff will become sick, and you'll get sick building syndrome and lots of calls for maintenance, etc. So you want to avoid all of that. So sometimes, yeah, fans are put into these little boxes to help them the performance. Alright, that's it for this video. Thank you very much for watching. Please remember to subscribe, like and share the video. And if you have any comments, please leave them in the comments section below. I'll try to answer these as soon as possible, or some of the other users might be able to help you. Don't forget to check out our website, engineeringmindset.com, and you can also find us on Facebook, Twitter, Google+. Once again, thanks for watching.